Welcome to the Engineering Simulation Veterans Series, Part 3. My name is Dennis Nagy, and today I'll be presenting Engineering Simulation Meets the Cloud, Current Status and Future Prospects. The full abstract of this presentation is just listed here on slide 2 for reference. I'm not going to read through all this, but if you watch this or if you download the slides, you can see exactly in more detail what is being covered in this webcast. So what I'm going to be covering today are a number of things. I'm first of all going to say at whom is this presentation targeted. That leads to the question of what are engineers actually doing? How does engineering simulation, or CAE as many of us call it, help engineers do it better? What are the obstacles to more engineers making more effective use of engineering simulation? What is the cloud? The current status of engineering simulation in the cloud, and finally some remarks on the future prospects for better engineering via prudent use of the cloud, including in particular the role of the UberCloud HPC experiment. So before I get started, just a few words about who I am. I'm basically a career CAE engineering simulation expert, having worked in a variety of different positions from research and academia all the way through to executive management of some of the leading CAE software companies. So you can see the details here. Currently, I'm an independent consultant. I'm the principal at a company of mine called BeyondCAE. I'm also the mentor, or a mentor, of the UberCloud HPC experiment, which I'll talk a little bit about later in this presentation. And finally, I'm a member of the NAFEM's American Steering Committee. If you click on any of these logos during this presentation, or any of the other links for that matter, when you download the slides, you'll be able to find out more about the different companies or activities that are being referenced here. So, who am I targeting this presentation at? Even though I've spent almost all my career on the vendor or ISV side of engineering simulation, I think there are plenty of sources of vendor views on how the cloud does something beneficial for, and you can fill in the blank there, and that whether that's the cloud or how a particular ISV does something. I don't need to repeat any of that here. So I'm trying to look at this topic from the engineering end user and engineering end user management viewpoint to provide some introduction for that audience to navigating the cloud opportunities and, frankly, some of the hype that accompanies any new subject that is still growing and emerging into its full maturity in the marketplace. If you remember, if you've watched any of my previous webcasts, there was a slide called the Engineering Simulation Food Chain, which I've repeated here. And without going over it again, I'm just pointing out that I'm concentrating at this point on the end user view of this topic, which is really very much linked to innovation. So for a few seconds, let's go back to basics. This should be obvious to most everybody, but I wanted to restate it. Engineers are developing or designing in a physical functional sense products, systems, and processes to meet or hopefully even to exceed a set of captured and understood requirements. That's a whole other subject. I won't get into what that really means, but the functional requirements involve the expected physical behavior of what is being developed, as opposed to just the aesthetics of it, which is partly what design is beyond the physical and functional sense. Anything that will assist engineers and their corporate management in judging whether requirements will be met is helpful here, obviously. The design, build of physical prototypes, and then the test and modify workflow cycle, or as they once called it in aerospace, the build them and bust them approach, has been more and more supplemented and replaced by engineering simulation. So how does engineering simulation, or CAE, help engineers do their work better? Quote, it provides the possibility of examining the functional behavior of product and process designs much earlier and more quickly than physical prototype testing. So this can allow engineers to gain further functional insight, the aha moments of that previous slide, and try more and more radical outside-the-box ideas during development, and or they can allow for a significant speed up in the development cycle. There's a freedom to trade off here. Either look at more possibilities, be more innovative, or get the development done more quickly if market pressures require that to be the primary goal here. All of this, though, really depends on one big if, that the simulations are realistic enough and fast enough. And that's a joint judgment call by development engineers, simulation experts, and their management. Fortunately, engineering simulation has reached this if milestone in many major industries and larger manufacturing companies today. Here's a very recent presentation by Greg Schroede from the Center for Automotive Research in Ann Arbor that he gave a few weeks ago. These are 3 of his slides, and I wanted to point out in particular that he does highlight the increasing reliance on simulation tools, and then states that simulation tools have moved from an added bonus to essential. And I think that's something that quite a few of us agree upon at this point. So what are the obstacles to more engineers making more effective use of engineering simulation? Despite simulation's success so far, there are still key obstacles. One of which is a very blatant situation that most of us who are involved in simulation tend to forget, is that the majority of practicing engineers in the world do not use simulation today. And I'm not counting spreadsheets here, I'm counting real software that is running some form of physics-based simulation. Users and potential users of simulation encounter 3 main obstacles, in my opinion, to not using simulation. It's the cost of the software, the cost of adequate computer hardware to run that software on, which leads in many cases to sort of a chicken and egg budget justification where engineers in some activity might want to do simulation and they might realize that or believe that it can help them, but they can't convince their management to license the software and to get adequate computer hardware to run it on. A third obstacle is that there's not enough knowledge or expertise among those engineers to use today's generation of engineering simulation software effectively, and that is a judgment call what effectively means, or even to use it at all, that is even to figure out how to get anything to run meaningfully in today's generation of software. If you haven't done it before, haven't had a significant amount of training, or don't have a expert to mentor you right within your own company. This whole area of knowledge and expertise in today's generation of simulation software is a topic for a whole different presentation, and I'm not going to really get into that anymore here. However, the other 2 obstacles are in fact where the cloud comes in to play a significant role here, and that's what I'm going to be talking about. So at this point then, it brings up the question, because it's relevant to this engineering view of getting value out of simulation, what is the cloud? There's a bunch of different definitions, and if you go in Wikipedia, the one I like because it's short and sweet says, in common usage, the cloud is essentially a metaphor for the internet. Marketers have further popularized or hyped, depending on how you look at it, the phrase in the cloud to refer to software, platforms, and infrastructure that are sold as a service remotely through the internet. Some people have said cloud computing is the next stage in the internet's evolution, Internet 3.0 or 4.0, Those are a lot of the hype jargon, but basically what it's saying is if you're going to run something in the internet, accessing it through a browser, then you're doing that essentially in the cloud. Another website called NetLingo has a good definition: a style of computing in which dynamic, scalable, and virtual resources are provided over the internet. That's the cloud. Cloud computing refers to services that provide common business applications online which are accessed from a web browser while the software and data are stored on remote servers, quote, in the cloud. In other words, access to both computer power and data storage capacity remotely via the internet through a browser, or if you stretch the definition a little bit, you could say it's through a very thin client user interface that you might have to install. Sometimes it's even a plug-in in your browser. And there are really two parts then of the cloud. There's HPC, or high performance computing, which sometimes is called HPCC, or high performance computing cloud. And then there's the other acronym or term called big data, and I won't get into that here either, because even though it is relevant at some point to doing very large involved simulations in the cloud, compared to what really is meant by big data today, it's really not a big issue. It's the high performance computing part that plays a role here. There is a more detailed and definitive definition of the cloud. The National Institute of Standards and Technology put out a few years ago a 7-page definitive answer and some recommendations related to the cloud. I won't read that whole text here, but that's the key excerpt from their executive summary. And they talk enough about it in those two publications that you really ought to take a look at it if you'd like to get a little more detailed definition. These NIST publications are available on the internet. When you get into this, you begin to see that there are some other terms. One is called public cloud, where all infrastructure components, including the servers, the actual computers, are shared among customers or clients. Potential contention exists for server resources in that situation because the servers are a finite size, and depending on how many people are trying to use them, they may find a bind or not get access to enough to get their work done when they want to. But it is the lowest cost version of doing something in the cloud. Virtual private clouds are where servers or portions of servers are dedicated to a company or enterprise, so that to you, the user, it looks like you have your own cloud fully dedicated to you, and it's private in many ways, one of which is that you're not contending for those resources when you've reserved them. Also, you have the feeling, if not necessarily the reality, of more security. Application performance is a little more guaranteed because you know how many nodes and cores in a cluster, for example, you have access to. But it's a little more expensive because you have to reserve some portion of hardware in the cloud. Either one of these models, owned and operated by a third party, that's the key point here, is less expensive than building your own or another type of infrastructure. That's a quote from Linda Stadtmüller, and you can click on that link if you want to go and read a little more about what she has to say in their Frost & Sullivan Cloud Computing Report. And then finally, there's an actual private cloud where your company owns or leases the hardware as well, and your ID department makes it look like a cloud to you. In other words, you access it through a browser. They take care of all the details behind the curtain, but it's all inside your firewall. This may be cost competitive with external clouds if there's enough demand and use. The key here is that it looks like a cloud, it's browser-based, and ease of use. Whether it's cost competitive with virtual clouds and public clouds is also not something I'm going to get into here in this presentation. So what are the potential benefits of the cloud for engineering simulation? When software and hardware access is priced appropriately, and that's a very qualitative or value judgment, both overflow needs and new user needs can be met incrementally, or as we more and more refer to it, by the drink. You can order a drink at the bar. You don't have to buy an entire bottle. More realistic, affordable business models. This is clearly a more realistic, affordable business model for small and medium enterprises and businesses. The proverbial missing middle, because they can step into using simulation and serious simulation in a more incremental way, and don't require a step function budget justification for an annual or perpetual license for software and a significant size cluster perhaps to run it on. It's a more streamlined user access experience to allow engineers to focus on engineering instead of the IT details. Eventually, it can even be a permanent solution for overflow from your in-house hardware resources, or even a replacement for in-house IT infrastructure by using the cloud third-party remote services and the providers of those in a separate. This is a separate debate or discussion, as I just mentioned before. There are many articles and white papers that talk about the potential benefits of the cloud for engineering simulation. In particular, one interesting thing that I found was last month, somebody in one of the LinkedIn groups just asked the question, what are the top 3 benefits of the cloud? And they got a lot of response. So it forms a recent LinkedIn users ad hoc survey of top benefits. And here are basically the ones that showed up and how many people voted for each one. So is this a good analytical survey? Probably not, but it does show a lot of current opinion about what people consider important. You can go to that LinkedIn group and look at a lot of people's comments that led to these votes. So at this point, let's talk a little more in detail now about what are the main layers of the cloud, because there are clearly layers involved in getting from actual hardware out there somewhere in the world to you using it as a person. So cloud clients are generally, as I said, web browsers or mobile apps, thin clients, terminal emulators, and so forth. That's how you interface with the cloud. And all of those, what they have in common is that they actually all go through the internet to get to the cloud. But once you get there, there are 3 layers. There's software as a service, platform as a service, and finally infrastructure as a service. There are people who offer all 3 of those from the same vendor. There are some vendors that offer the first 2, but then go out the back end to actual infrastructure providers. Again, this is just getting you familiar with the terminology rather than going into a lot of detail about who these vendors are of each of these layers. This is a good graphical way to look at it, where you, the user over on the left, can access through the internet the cloud in whatever way you're trying to access it, whether it's engineering simulation, Salesforce.com, sales management, or whatever. But you really can access it through smartphones, personal computers, laptops, notebooks, and so forth. And that's really all theoretically that you should care about it. And behind the internet are the cloud providers, who then provide some variety of software as a service, platform as a service, infrastructure as a service, and so forth. The cloud marketplace has clearly become very big and fairly rapidly. Here you see from IHS a list of, or a graph of how much is being spent globally by enterprises on cloud architecture, and it's gone from somewhere around $75 billion in 2011 to a projected almost $250 billion in 2017. A little bit of further refinement in this one layer called software as a service, I think, is necessary in the area of engineering simulation, because as those of us who've done simulation or vended it, sold it, and so forth know that there's really 2 parts to things like finite element analysis, computational fluid dynamics. There's the GUI, the user interface, and then there are the batch solvers. You normally prepare things to be run as a simulation in a GUI or user interface, but when you actually send it off to be run, it takes long enough that you just don't want to sit there and wait. You want to continue doing something in the GUI, looking at results of a previous run or preparing the next run and so forth while something is running in the background in a so-called batch solver. So you have two layers of software as a service. You have the GUI layer and the batch layer. Some vendors provide both, some provide one or the other. And a lot of it has to do with whether you're going to be doing your interactive work locally on your own computer and just sending something to the cloud to crunch in batch mode, or whether you're going to do it all in the cloud. So the question is, where is the pre and post processing done? A lot of that then has to do with cost and speed of data transmission to and from the cloud. And particularly after you've run something, how do you look at the results? Do you have to bring back a very large results file before you can visualize it? Or can you visualize it somewhat in the cloud and at least see whether you didn't just make some dumb mistake in your input and you don't really want to bring that entire file back? You just want to fix the mistake and run it again. And so visualization from the cloud has a lot to do with pushing the minimum amount of data so that you can visualize in your browser, or pushing pixels only. To talk quickly about the infrastructure as a service, because that's that foundation layer that really is where everything happens. It's the hardware and whoever is providing it, with or without the other layers above it. Gartner is probably the largest information technology market analyst company in the world, and they put out, for a lot of the different areas of information technology that they follow, they put out periodically what they call their magic quadrant. And if you look on the left-hand side of this four-quadrant diagram, you'll see a category called ability to execute, and in the horizontal you see completeness of vision. In other words, they try to place different vendors in their opinion on both how complete is their vision and how much can they actually today execute on that vision. This is the one they put out last August. And the key point of putting this up, other than to make you aware of these kinds of diagrams and of Gartner as an analyst company, if you're not aware of them, is that this is something they put out back in August 2013, which is only about 9 months ago. And it shows at that time that Amazon Web Services in the IaaS segment is clearly the leader by far. And as Rory O'Driscoll said in his comment here, he's at Scale Venture Partners, he said Amazon Web Services is the only possible winner. Well, that was 9 months ago. But the question is also, this market is highly competitive, and that the situation may change very fast. Makes you ask the same question today, and the first question I asked when I saw this, of course, is where is Google? Because they've made it clear more recently that they are going to compete in this market. So maybe they're not on that diagram at all, but they don't want to keep that situation for very long. So let's get specific now about engineering simulation, CAE, and who are the relevant cloud players in any and all of these layers. Well, I've listed here on the right-hand side who are the commercial cloud vendors that play in the engineering simulation market, either as infrastructure, platform, or software as a service providers. This isn't a complete list. It's a list of ones that I'm aware of, that I've come across, that I've either met people or visited some of them in person, interviewed them. But there are plenty others because it's a dynamic market and they're popping out of the woodwork almost as fast as you keep looking for them. So as I do this presentation, there's probably one or two more that could appear on that list. Then there's ones that are non-profit. In other words, even though they charge for the use of the cloud, they are not a profit-making company. They're either government or university organization that is trying to play in the cloud space. This is another nice graphic because it kind of shows how the whole thing fits together for enabling software as a service for a particular independent software vendor that would like to do that. They get a lot of help from various clouds vendors, and so there is a core service. There are various customers that then want to make use of that. They all do it through the internet, and to the customers, in this case, independent software vendors, their site, their website, and their portal for cloud access to their software can look like it's unique, but in fact, it may all be hosted at the same place. The focus important here, both for engineers and for ISVs, is they should all focus on your core competency, which is innovative software development and innovative use of simulation. Let the other experts deal with everything behind the curtain. So here's where the rubber meets the road. Depending on the size of your terminal, this may be a little hard to read. It's not meant to be an eye test. If you download the slides, you of course can see this, and then you can zoom in and look at it in a bigger font size if you want to. But what you see across the top is my list of vendors and cloud providers that I showed on that previous slide. And then down the left-hand side are a list of a lot of the software vendors, the ISVs that provide simulation software, both in MCAE, mechanical CAE, and a few in the electronic CAE and electronic design automation space, although that's not really the focus of this particular presentation. It's also not the focus of my expertise compared to what I know about MCAE. But here's a whole bunch of companies and the software they provide. If any of you see software that you use but you don't see it there, send me an email and I'll figure out whether they're in the cloud and I'll add it to the list. But what I'm showing here is how these different MCAE providers actually have a cloud presence. Where and through whom are they actually placing their software on the cloud? Are they doing it themselves? Are they doing it through a software as a service aggregator, a platform as a service, or directly with the infrastructure as a service providers, or are they doing it through some of these nonprofit cloud opportunities? Now I want to get a little more into cloud-related efforts to reach the missing middle, the small and medium enterprises or small and medium businesses, because that's a particular focus of a lot of the cloud activity, because as I showed in an earlier slide, that is a more manageable or affordable way for small and medium enterprises to try out simulation in the cloud with relatively little investment, or even in some cases no investment. There are four different activities here that I want to focus on, one of which I'll talk more about, and the other three I want to at least call your attention to. I will be talking more about the UberCloud because I am a mentor in that activity and because they're also hosting this webcast. The other three, though, that you could take a look at, and they're not the only three, but they're three that I happen to be more well aware of, is an activity through the National Center for Manufacturing Sciences, another one called Blue Collar Computing, which is related to the Ohio Supercomputing Center, and an activity called AWSIM, and then a European activity that's just starting up called Cloud SME. If you click on any of these three images here in your copy of the slides, you'll go to websites that will provide you with more information. Now about the UberCloud HPC experiment, though. It's an open, voluntary, collaborative community that has the objective of making HPC as a service available for everybody on demand. That's the ultimate objective, but it's starting out very practically by just seeing how easy or hard is it to do that. And it's exploring the end-to-end process of using remote computing resources as a service on demand at your fingertips, so to speak, and learning how to resolve actual real roadblocks that might be there today to doing that. This UberCloud HPC experiment started in August 2012, and by today, April 2014, it's got over 1,300 registered organizations and individuals. People can register just as observers, or they can register as an end user who wants to participate in this, or as an ISV who wants to have their software participate in one of the teams, a research provider that wants their hardware to be used, or an HPC expert that would like to manage a team and actually be part of one of the teams in this experiment. There are participants from 48 countries, maybe more by now. Round 5, each round is about 3 months. Round 5 started at the beginning of February and it's coming near the end now. There are 25 to 30 new teams in each round. Some of the round teams are carryovers from previous rounds if they didn't finish and want to continue. So that in total, because they keep getting numbered and formed successively, there are well over 140 teams that have been formed. You can go to any one of these URLs, these links here, to register if you'd like to find out more and be an observer, or jump into the pool and participate. There was a poll taken almost a year ago now, and it's been taken a few times since then, to ask people involved with some of these webcasts what the major challenges are in HPC. And as you see there are some of the results. These are not by any means scientific. For example, we had on the 3 webcasts that I've done so far, we've had probably 60-some people actually taking this poll because they were watching the webcast live. But these results are generally true today still. I think maybe the intellectual property and data security concerns have come down a little. Software licensing is still a big issue because a lot of the vendors haven't really streamlined that, and so forth. Is cloud security or privacy really an issue? Because that was shown a year ago to be the most important, and even today is still considered important. It's clearly in the eye of the beholder. There's no analytical way to define whether you have enough security or privacy. Major cloud data centers and hosting are well aware of these issues and have good technical and legal security and privacy infrastructure. I mean, it's their bread and butter, so they are very aware of it. Many in-house users of software and internet access are not aware of how insecure and exposed their data and computing might be. And of course, somewhat jokingly, here in the US at least, we can say the NSA has and sees everything anyway. This sounds funny to us in the US, but it's not really a joke for non-US users and prospects for US-based cloud data providers. And they're trying to deal with that by locating some data centers in other places than within the US, even if they're a US-based company that has the data center. There's a very good Autodesk white paper, in fact, on this topic, because Autodesk 360 is a very big cloud effort by Autodesk, and they really had to address this directly and explicitly. They have said, with over 10 years of experience providing cloud-based solutions, Autodesk knows that data security is critical to your success. There's another interesting survey that was just done recently by a company called RightScale, and they looked at, they've surveyed over 1,000 people that are at least cloud knowledgeable and or using the cloud, to see what they thought about cloud security, how significant a challenge did they feel it was. And as you see here, the challenge of cloud security is declining with people's maturity and with the year in which the survey is taken, meaning it's less now than it was a year ago, and it's much less among people who are cloud focused rather than people just beginning or exploring. Some of the technical hurdles encountered in the HPC UberCloud experiment were in the area of the downloading speed of large results files for local visualization. I mentioned that before briefly in the idea of, do you want to push pixels or bring entire files back? To the extent that you can determine whether a simulation was really good and you want to save it and archive it locally, that's when you ideally should bring those files down, and you shouldn't have to sit there and wait for it. You can do that offline or in parallel with other things you're doing. The remote visualization of results then, for if you don't want to download these large result files, was a key issue and still is in some of these teams. They made use of general purpose remote visualization tools. In some cases, even when they did that, they found a bit of a lag in looking at results because the so-called last mile of their connection to the internet was the bottleneck. If you're aware of the fact that a lot of people have internet access, even fiber optic, through a shared fiber optic cable. I know I have that here in my home office. The more people using that last mile along with me, the slower my connection is. Also, if you're trying to use a data center or a cloud that's actually about halfway around the world, you can only push pixels so fast before you run into the speed of light as a limitation. And that, in fact, is a limitation in trying to visualize some fairly complicated and elaborate images when you're halfway around the world from where that image is being created. And then the other main technical hurdle that was encountered by a number of the teams was that the cloud access mechanisms that were available when they started doing their actual team project were complicated and somewhat non-intuitive. They involved too much having to figure out what port are you accessing, which files, and so forth, which in the future ideally should not be a concern if you're an engineer trying to use the cloud. There are a lot more details on the UberCloud experiment, on the successful teams, particularly from rounds 1 and 2. There was a nice publication that was sponsored and published by Intel of the 25 best teams from rounds 1 and 2. There's a nice 3, 4, 5-page summary on each one of those teams, what they were trying to accomplish, what their application was, what did they run into, and how did they overcome it. All you have to do is click here on this slide and you'll be taken to a place where by registering you can get a free PDF copy of this compendium. They are in the process of publishing a follow-on for rounds 3 and 4 that will be very similar to this and have more information from later rounds. In particular, what these teams are and what that compendium is really a collection of use case studies. And the next UberCloud TechTalk webcast, the one following the one that this recording is related to, will in fact present one of those in detail. It's called Flash Dryer Simulation with Ansys in the Cloud. It's going to be on Wednesday, May 7th. Between 8 and 9 a.m. Pacific Daylight Time and whatever the equivalent time zone is anywhere in the world. So I'd suggest if you're interested in watching that and you're listening to this recording before May 7th, go and sign up for that. And if it's after May 7th, then you can listen to that recording just the way you're listening to this one. Again, on this slide, you can click to register for it, or you can go to the UberCloud website and you'll find a possibility to register there as well. Also, there are further cloud simulation relevant information sources in a lot of places. I just tried to put a few of them here that are in LinkedIn because I think probably a lot of you are members of LinkedIn. If you haven't joined some of these groups that are related to engineering simulation and or cloud computing, you should do so. There's a group that's probably the best in this area for cloud-related discussions. It's called New Trends in CAE Simulation. If you click on that link here on this slide, you'll be taken there. Or if you want to go straight to some of these discussions, you'll see here that there are a number of discussions. One called What Does It Mean for Software Resellers, the cloud. If you're a ISV or a software reseller, you'll want to look at that discussion because there's a lot of fairly well-known people who've commented on that. There's also one on software licensing in the cloud, CFD, CAE software on Amazon Web Services, and so forth. So I would strongly encourage you to go take a look at these. Also, a number of the discussion groups that are more general on cloud computing, but have some interesting discussions related to topics that would be of interest to you as an engineering simulation person. So this is sort of my simplified final slide here on what I think of as the cloud's potential as a true utility. In other words, today, as an ordinary person who wants to make breakfast, if I want some toast, I plug my toaster into the wall, stick a slice of bread in it, push one lever, and I get toast. I don't care about where those electrons are coming from behind that plug in the wall to operate my toaster. I don't care whether they were generated. I mean, I do care, but that's another subject. I don't really need to know whether they came from a coal-fired, an oil-fired, a natural gas power plant, solar energy, wind energy, tidal energy, or whatever. That is a whole separate issue, and that all exists behind the plug. The engineer using the cloud in the future should really at some point get to that point where whether you're using a laptop, a notepad, pressing a particular key on a keyboard, even using things like Google Glasses and other forms of accessing the internet while looking through your eyes in a pair of glasses, that's all you should care about. You should not have to know what all is behind there and getting that information to you in a way that you can make use of it. We've got a ways to go to get there, but everybody's working on it, and so I'm pretty optimistic that we'll get there someday. Exactly which day is, of course, a lot harder to predict. So clearly the cloud is coming to engineering simulation, or vice versa. Engineering simulation is coming more and more to the cloud. It's only a question of how rapidly. Here's a good quote from somebody at salesforce.com that says, it's hard to tell when a novelty becomes a trend or a trend becomes the new normal. This is not one of those times. The area of on-premise server is clearly behind us, with the cusp of change literally on our calendars. Well, that may be a little too optimistic when it comes to engineering simulation because we're dealing with engineers, and as we all know, we're more conservative than maybe the general public and the people on social media. But still, this is clearly what's happening because there's money to be made. And wherever there's money to be made, you can be sure somebody will figure out how to make money while you and I benefit from whatever they have figured out. So anyway, that's really all I had to say here. I saw a great cartoon just a couple days ago on Facebook where a little girl is asking her mother, "Mama, what is normal?" You know, because here you see on this slide the new normal. So the little girl asked her mother, "What is normal?" And the mother said, "Yeah, it's a setting on our dryer, that's all." So anyway, with that, thank you very much for watching and listening to this webcast, and I hope you contact me and register for the UberCloud and watch some of the other ones that will be shown there. Thank you.